Alright, the next thing we're going to look at is solving equations that have absolute value in them. Okay, so looking at this first example, those straight bars that are around the x mean absolute value. So we read that the absolute value of x equals 51. We want to find out what values for x would be true to make that equation true. So if you take the absolute value of 51, that equals 51. And if you also take the absolute value of negative 51, that also equals 51. So x could be this value, and it could also be that value. So x equals 51, and x equals negative 51. Alright, so if we look at this equation, we got the straight bars around the x plus 4, so we read this, the absolute value of x plus 4 equals 3. Well, we know if we had the absolute value of 3, that equals 3, and if we had the absolute value of negative 3, that also equals 3. So all of this x plus 4 could equal 3. It could also equal negative 3. So I'm going to say, okay, so we got x plus 4 could equal 3, or x plus 4 could equal negative 3. So if we had that inside that circle here, if we had 3 in there, that would be true. And if we had negative 3 in there, that would be true. So if we go ahead and solve this here, we would subtract 4 on both sides. So x would equal negative 1. Or if we solve this one, if we subtract 4 on both sides, x is going to equal negative 7. Now if we check that, just to make sure we got the right answers here, if we plug in absolute value of negative 1 plus 4, does that equal 3? Well, negative 1 plus 4 is 3. And is the absolute value of 3 3? Yeah, so that answer, this answer checks out. That's correct. If we do the same thing over here, if we plug negative 7 in for x, take the absolute value, is that equal to 3? Well, negative 7 plus 4 is negative 3. Does the absolute value of negative 3 equal 3? Yes, it does. So this is also an answer. So we could have x equals negative 1 or x equals negative 7. Alright, so here we've got the equation 3 times the absolute value of the quantity 4x plus 2, and then it ends the absolute value, minus 7 equals 11. So we're going to treat this like a two-step equation. Going to worry about getting rid of the subtracting by 7 on both sides because we want to get the absolute value of 4x plus 2 by itself. So if we add 7 to both sides, we then have 3 times the absolute value of 4x plus 2, and that equals 18. And then continuing on from here, since we've got 3 times all the absolute value, because we want to get the absolute value piece by itself, since it's being multiplied by 3, we're going to divide all of this by 3. And if you divide that side by 3, you've got to divide the other side by 3. That becomes 1. So then you have 4x plus 2, the absolute value of that, equal to 6. And that means that everything inside of here could be equal to 6, or it could equal negative 6. So I'm going to bring that up over here. We've got 4x plus 2 equals 6. And we also have 4x plus 2 equals negative 6. So solving this one, going minus 2 on both sides, we have 4x equals 4, divide by 4. So x could equal 1. That's one of the possibilities. If we solve this one here, subtract 2 on both sides, we have 4x equal to negative 8, which means x can also equal negative 2. Okay, so those are 2 answers for that one. Alright, so for this one here, we got the absolute value of quantity y minus 4, and then plus 8 equals 6. So we want to solve this if we can. So if we start off by subtracting 8 on both sides, we have y minus 4 equal to negative 2. When we take the absolute value, we're talking about the distance something is from 0. So it's always, I talked about in a positive way. So if you look at this, since it equals negative 2, you can't have the absolute value of something be negative. So this is not possible. Therefore, there are no solutions. The absolute value of something can't be negative.